Hey there, and welcome to this lesson on the binomial theorem. Student objectives: define and apply binomial theorem. So our essential question: what is the binomial theorem, and how will it help us with polynomial expressions? Common Core standards: write expressions in equivalent forms to solve problems. So what is the binomial theorem exactly? Binomial theorem is a method for distributing powers of binomials. So when you have a binomial and it's multiplied a certain number of times, like you can see down here in this example, a plus b to the fourth, there's a certain way every time those binomial the way the binomial is multiplied, there's a certain pattern for what your terms of that binomial is going to be, or what it's going to look like. Khan Academy does a great job of breaking down the binomial theorem and explaining it in a way that I think is very beneficial to you. So go ahead and watch this video from the Khan Academy, and then we'll meet back afterwards.
It doesn't take long to realize that taking higher and higher powers of binomials can get painful. But let's just work through a few just to realize how quickly they get painful. So if we take the binomial a plus b, it's a binomial because it has two terms right over here. Let's take that to the 0 power. Well, anything that's non-zero to the 0 power, that's just going to be equal to 1. Well, that wasn't too bad. Now what about a plus b to the first power? Well, that's just going to be a plus b. Now what about a plus b squared? Now, if you haven't been practicing taking powers of binomials, you might have been tempted to say a squared plus b squared, but that would be incorrect. If you did that, you should give yourself a very gentle but not overly discouraging slap on the wrist or the brain or something. A plus b squared is not a squared plus b squared. It is a plus b times a plus b. And then if you do this, it'll be a times a, which is a squared, plus a times b, which is ab, plus b times a, which is another ab, plus b times b, which is b squared. You have two ab's here, so you could add them together. So it's equal to a squared plus 2ab plus b squared. Now things are going to get a little bit more interesting. What is a plus b to the third power going to be equal to? And I encourage you to pause this video and try to figure that out on your own. Well, we know that a plus b to the third power is just a plus b to the second power times another a plus b. So let's just multiply this times a plus b to figure out what it is. And I'll do this. So let's see. Let's multiply that times a plus b. So I'm just going to multiply it this way. So first I'll multiply b times all of these things. So I'll do it in this green color. B times b squared is b to the third power. B times 2ab is 2ab squared, so 2ab squared, and then b times a squared is ba squared, or a squared b, a squared b. So all I did is I multiplied b times all of this stuff. Now let's multiply a times all this stuff. A times b squared is ab squared, ab squared. A times 2ab is 2a squared b, 2a squared b, and then a times a squared is a to the third power. And now when we add all of these things together, we get a to the third power plus, let's see, we have 1a squared b plus two more a squared b's. That's going to be 3a squared b plus 3ab squared. 2ab squared plus another ab squared is going to be 3ab squared plus b to the third power. So just taking something to the third power took us a reasonable amount of time. And so you can imagine how painful it might get to do something like a plus b to the fourth power. Or even worse, if you were trying to find a plus b to the 10th power or to the 20th power. This would take you all day, or maybe even longer than that. It would be incredibly, incredibly painful. And that's where the binomial theorem becomes useful. So what is the binomial theorem? Well, the binomial theorem tells us, let me write this down. Binomial theorem. binomial theorem, it tells us that if we have a binomial, I'll just stick with the a plus b for now. If I have, and I'm going to try to color code this a little bit. If I have the binomial a plus b, and I'm going to raise it to the nth power. I'm going to raise this to the nth power. The binomial theorem tells us that this is going to be equal to, and the notation is going to look a little bit complicated at first, but then we'll work through an actual example, is going to be equal to the sum from k equals 0 to n, this n and this n are the same number, of, I don't want it, that's not kind of a garish color, of n choose k. N choose k, and we'll review that in a second. This comes straight out of combinatorics. N choose k times a to the n minus k, times b to the k, b to the k power. Now this seems a little bit unwieldy, and let's just remind ourselves what n choose k actually means. So if we say n choose k, I'm going to do the same colors, n choose k, we remember from combinatorics this would be equal to n factorial over k factorial times n minus k factorial. N minus k factorial. So n minus k factorial. Let me color code this. N minus k factorial. So let's try to apply this. And well, let's just start applying it to the thing that started to intimidate us. Say a plus b to the 4th power. So let's figure out what that's going to be. Let's try this. So I'm going to try to keep it color coded so you know what's going on. A plus b, although it takes me a little bit more time to keep switching colors, but hopefully it's worth it. A plus b, let's take that to the 4th power. So the binomial theorem tells us that this is going to be equal to, and I'm just going to use this exact notation, this is going to be the sum from k equals 0 to 4 of 4 choose k, let me do that k in that purple color, 4 choose k of a to the n or the 4 minus k power, times b to the k power, Now what is that going to be equal to? Well, let's just do the sum. This is going to be equal to, so we're going to start at k equals 0. So when k equals 0, it's going to be 4 choose 0 times a to the 4 minus 0 power. Well, that's just going to be a to the 4th power times b to the 0 power. Well, b to the 0 power is just going to be equal to 1. So we could just put a 1 here if we want to, or we could just leave it like that. So this is what we get when k equals 0. And then to that, we're going to add when k equals 1. So k equals 1 is going to be, the coefficient is going to be 4 choose 1. And it's going to be times a to the 4 minus 1 power. So a to the 3rd power, and I'll just stick with that color, times b to the k power. Well, now k is 1, b to the 1st power. And then to that, we're going to add 4 choose 2 times a to the, well, now k is 2. 4 minus 2 is 2, a squared. I think you see a pattern here. A to the 4th, a to the 3rd, a squared. And then times b to the k. Well, k is 2 now, so b squared. And you see a pattern again. So this is, you could say b to the 0, b to the 1, b squared. And we only have 2 more terms to add here. Plus 4 choose 3 times 4 minus 3 is 1 times a, or a to the 1st, I guess we could say, and then b to the 3rd power times a to the 1st, b to the 3rd, and then only 1 more term, plus 4 choose 4, choose 4. K is now 4. This is going to be our last term right now. We're getting k goes from 0 all the way to 4. 4, choose 4. A to the 4 minus 4, that's just going to be 1. A to the 0, that's just 1. So we're going to be left with just b to the k power, and b is 4 right over here. So we're almost done. We've expanded it out. We just need to figure out what 4 choose 0, 4 choose 1, 4 choose 2, etc. are. So let's figure that out. So we could just apply this over and over again. So 4 choose 0, 4 choose 0 is equal to 4 factorial over 0 factorial times 4 minus 0 factorial. So that's just going to be 4 factorial again. 0 factorial, at least for these purposes, we are defining to be equal to 1. So this whole thing is going to be equal to 1. So this coefficient is 1. Let's see, let's keep going here. So 4 choose 1 is going to be 4 factorial over 1 factorial times 4 minus 1 factorial. 4 minus 1 factorial, so 3 factorial. Well, what's this going to be? Well, 1 factorial is just going to be 1. 4 factorial is 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1. Let me make that clear. 4 times 3 times 2 times 1 over 3 times 2 times 1. It's just going to leave us with 4. So this right over here is just going to be 4. Then we need to figure out what 4 choose 2 is. 4 choose 2 is going to be 4 factorial over 2 factorial times, what's 4 minus, what is going to be n minus k, 4 minus 2 over 2 factorial. So what is this going to be? Let me scroll over to the right a little bit. So this is going to be 4 times 3 times 2 times 1 over 2 factorial is 2, over 2 times 2. This is 2, this is 2. So 2 times 2 is the same thing as 4. We're left with 3 times 2 times 1, which is equal to 6. So that's equal to 6. And then what is 4 choose 3? Actually, I'll use some space down here. So 4 choose 3, 4 choose 3 is equal to 4 factorial over 3 factorial times 4 minus 3 factorial. So that's just going to be 1 factorial. Well, we already figured out what that is. That's the same thing as this right over here. You just swap the 1 factorial and the 3 factorial. So we already figured out that this is going to be equal to 4. So that is equal to 4. And 4 choose 4? Well, this is just going to be, let me just do it over here. 4 choose 4 is 4 factorial over 4 factorial times 0 factorial, which is the exact thing we had here, which we figured out was 1. And just like that, we're done. We were able to figure out what a plus b to the 4th power is. It's 1a to the 4th plus 4a to the 3rd b to the 1st plus 6a squared b squared plus 4ab cubed plus b to the 4th. And actually, let me just write that down since we did all that work. This is equal to a to the 4th plus 4 a to the 3rd b plus 6 a squared b squared plus 4, I think you see a pattern here, plus 4a times b to the 3rd power plus b to the 4th power. Plus b to the 4th power. And there's an interesting pattern here. There's a symmetry where you have the coefficient, you go 1, 4, 6 and for the middle term, and then you go back to 4, and then you go back to 1. And then you also see that pattern is that you start at a to the 4th, a to the 3rd, a squared, a, and then you could say there's an a to the 0 here. And then you start at b to the 0, we didn't write it, but that's just 1. Then b to the 1st, b squared, b to the 3rd, b to the 4th. So this is just one application or one example. In future videos, we'll do more examples of the binomial theorem and also try to understand why it works.
Here is your homework for the binomial theorem lesson. The first two, it says coefficient of x squared, an expansion of 2 plus x to the 5th for the first one, and x plus 2 to the 5th for the second one. So you are just going to give me the coefficient for that term, okay? And then the next two, no, okay. So you're just going to be giving me the coefficients for each of the terms described in the binomial expansion. Okay, you can write out each one if you want all the way and then find the term, but you may also be able to find a certain pattern and be able to tell me what that term is without even having to do the expansion. So go ahead and give this a shot. If you have any questions, feel free to reach out to me. BBIM, email, phone number, either one. They're all on the main Moodle, sorry, not the main Moodle page, but our course page on Moodle if you need to contact me. Also, I am in Math Cafe on Monday, Tuesday, and Wednesday at 11 o'clock. And there's also a teacher in there from 9 to 3 every day willing to help you on your assignments. So if you need help, be sure to reach out to somebody and we'll be glad to help you. If you don't need help, we'll see you in live class where we can get into this a little more in depth.